So I will begin this with the recent very hot topic, stretchable electronics. So the idea is nowadays people make electronic devices into this thin conformal form factor to the skin so that it can stretch together with the skin, and people use this kind of devices to measure EKG, EMG, EEG, heart rate, temperature, sweat, many physiological parameters of the body. However, these devices are not for imaging deep organs, and we know how important the imaging modality is for diagnosis of diverse diseases. Then, indeed, recently, people begin to try to make ultrasound into stretchable form factor. For example, Professor Xu's group at UCSD make a stretchable ultrasound so that this ultrasound probe can stretch together with the skin to image internal organs. However, it suffers from intrinsic challenges. Number one, acoustic wave is directional. Stretchable ultrasound probe need to conform to the skin, parallel to this skin. The resultant imaging direction is not optimized. You can see here, you miss the major reflection of the incoming acoustic wave. Number one, intrinsic challenge. Number two, ultrasound imaging requires accurate transducer positions. You need to know exact location of each of those transducers. However, the stretching, like stretching the image sensor of your cell phone, will introduce significant imaging errors. So these are intrinsic challenges that people know. So in 2022, we proposed a fundamentally different idea. So we call it a bioadhesive ultrasound. Instead of making the ultrasound probe to be stretchable, we make it into a thin, rigid form factor. It's an ultrasound patch, but thin but rigid. Then you may ask, how do you conform that ultrasound patch to different locations of the body? Then we introduce this soft bioadhesive couplet interface between the machine and the human body. So this couplet can provide a skin adhesion and conformation because it's very soft. It deforms together with the skin. It can give us optimized imaging direction. So think it this way. We can make this soft couplet to be different shape so that you can really optimize the imaging direction. No probe stretching or image distortion, and it can enable functional communication between the human body and the external machine. So that's the key idea. Thin, rigid ultrasound probe and a soft bioadhesive couplet. Then with that, I'll first tell you the big picture. We transform ultrasound imaging. So this is one of the most popular imaging modality in medical applications. But in the current practice, the clinician use a thick handheld ultrasound probe, spread liquid gel on the patient. The patient needs to go to a hospital to take a snapshot imaging. And the patient is also in static state, kind of move around. We transform this technology into something that is wearable. You can adhere this bioadhesive ultrasound patch to different locations of body. You can wear it even at home or in hospital. Now the imaging become long-term continuous. You can literally image organs over hours, even days. And then it's hand-free. Now you don't need to use a hand to hold this probe. Then you can put multiple patches on the body, and the patient can undergo dynamic body motion. So we transform ultrasound imaging into this new possibility, I would say.